Okay. Thank you everyone for coming in a post-lunch session. I hope you have a good nap in the next 45 minutes. If you don't want to sleep, that would be even better. Only if you're snoring, I would request you to go outside so we don't disturb the others. We are going to talk today about how can we enable continuous delivery in enterprises with testing. There have been a couple of questions about is this testing focused or what it is, more CD. The focus is on continuous delivery, but from the angle of testing. The prereqs for this talk in terms of who should attend, I say everyone who is part of the team. Okay. So anyone over here who doesn't feel part of the team, this session is not for you. Otherwise, everyone, this is going to be really required. And we also have a very good spread of various different roles in the room. Again, that is very important because it gives a very different perspective about what is going to take this to the next level. Very quick introduction about myself. I'm Anand Bagmar. I'm currently playing the test practice lead role in ThoughtWorks. I'm based out of Pune. I've been doing testing for about 18, 20 years, something, various different roles related with testing. And I'm still not bored of it because I think there's a lot more for me to still learn in this particular field. So I'm really very excited to continue on this path and also share what I have learned from experience, what I'm seeing on projects, and also in terms of what potentially happens in the future. I'm keeping an eye out on it in various different ways. So that's enough about me. What is it that you expect from the session? So what is continuous delivery? Of course, that's the first thing that comes up. And we will not be spending too much time on that question. Okay? What other thing are we expecting from this? Challenges in, okay, excellent. The challenges faced for implementing CD in large projects. Yes, we'll be covering that. How do we ensure continuous delivery? We'll speak about that.
Is it reality? Is it happening?
Excellent question. I have not heard that one before. Is it a myth or is it a reality? Is it really happening? And yes, it does happen. It does happen, and there are a lot of organizations who have really implemented a lot of good, set up a lot of good processes and practices, and have invested in the tool sets, capabilities, skills required to get them on the path. Netflix, Flickr are some of these few names who are on that path already. So yes. Okay. So is it going to be for web-based or maybe desktop applications of sort? What might be? I think it is going to be mainly for what should I put? Yeah, product development. I think is the easiest way out of that. We'll be focusing on a web-based interface. It's all about software essentially, right? So software could be in form of web-based deployment or actual installer-based deployment, and certain practices would need to differ based on the domain, the context for sure. But I'm sure there'll be certain things that you can take out of this and try and apply.
What are the norms for the continuous delivery and how you
The challenges in continuous delivery and what can you do potentially to overcome those? Yeah.
To enroll the team to continuous delivery.
Sorry?
How to enroll the team.
How to get the team on board to embrace continuous delivery. That's where the manager's roles are very important over here. Okay. Yes, we'll talk about some. You had some.
But this is more in relation to what
Okay.
the other person asked. That is it more, in your experience, do you see it more of a behavioral attribute or it is all about tools and techniques?
Okay, is continuous delivery more behavioral or more all about tools, techniques? I think it's a combination for sure. Not think, I'm sure it's a combination. Because without the right mindset, you wouldn't use the right set of tools and technologies to help support that. Okay. So I think we've got a fair set of expectations of sort. And Kshitij, I think we've got the doors closed. So it is not about any of that. We are going to prove a triangle is a pentagon. Okay. This is what we are going to prove, or rather I'm going to try and prove. And I want you to tell me at the end of the session if this is even feasible or not. Okay? Why do we do software development? Why do organizations, companies do software development? Reality is they have got three main reasons. One, they want to make money or provide value to its end users. Now that is the main drive for sure, right? There's an idea how do we implement it and get it in front of end users. But that is possible only if you get the product out in front of the expected users in proper time. Otherwise, again, no use. But what good is a product that you get in front of the users in good time, which is of poor quality? These three things are very closely tied to each other. To ensure that you get the right kind of adoption, the right kind of return of investment, you need to make sure you get it out on time and of the right quality. Now let's look at another reality. We are spread all across the world. The world is getting smaller, it's shrinking. Now, there are various reasons for this, and I'm sure we are part of organizations which have either seen this or we've seen it in our past experiences. So I'll quickly run through some of these. The reasons could be globalization, the cost factor, and various other things, right? We want to make sure we are getting the most value for our money and delivering as quickly as possible. So for that, we do need to spread out. Mergers, acquisitions keep happening to help widen the portfolio and give a better offering to end users, hopefully. That's the organization objective. And what we are going to talk about today is about a core banking implementation as a case study and what things we did on that project to get them on a path of implementing continuous delivery. Okay? Why I've chosen this? First, it was easy for me. It's a project that I worked on. It is close to me. I understand it in quite a few details. It is hugely complex, which is what we had some questions. How do we really implement this on large complex projects? So hopefully this case study will give you some correlation with what you are going through or you might have seen happening, and maybe there are some good takeaways out of it. Now, anyone in the finance domain over here? Couple of them. Okay? So, is it easy? Banking?
As long as I don't do it.
Exactly. It is hugely complex. Core banking is hugely complex. Now, for this particular bank that I was working in, an Australian bank, one of the largest banks in Australia, not the largest, but in the top few over there. This is how their distribution was. They were working out of Australia. The bank is majorly in Australia. They are offering products, services in New Zealand as well. But the development and implementation is happening from India and China as well. So it's spread across in certain ways. Now the scope of this engagement, why did the bank want to go on a core banking platform implementation journey? If this is a scope where the background weird shape is what is the core banking platform, it comprises of mainframes, lot of legacy systems, and on top of that there will be other systems in the bank which are relatively new. For example, internet banking is new compared to the mainframes, right? So a lot of such existing systems in the bank, as well as a lot of external interfaces that need to happen for that core banking, whether it's in form of regulations or other credit card providers, whatever it might really be in the banking portfolio. There will be a lot of internal systems and external systems sitting on top of the core banking platform. Now they needed to change this. Why? Because we know how easy it is to work with mainframes, how quickly we can make changes in mainframes, add new products and offerings from a banking perspective. So what they wanted to do is change this into this. The core banking platform had to be replaced, and the approach they took is to buy a off-the-shelf product, a banking platform product from a large organization. After whatever investigation they selected that one. But can you use any off-the-shelf product directly? You have to customize it based on what your needs are. Especially if it's a banking platform, you have to customize it based on what your country or legal requirements for your region, country are also, right? So there's a lot of customization work that needs to happen. So as part of that, the existing systems in the bank and the external interfaces remained the same in certain ways, but there had to be certain set of additional implementation customizations that were required. And in addition to that, the other existing systems also needed to be updated to work with this new flow. Okay? Likewise for the other external interfaces also. Now this was an even bigger challenge because can this be done by just a flip of a switch? Okay, I'm all done now, flip a switch, and now I'm on a new banking platform. Never works like that. Never like that. You would start by getting specific pieces of your platform from old system to the new system. Start migrating that. All new traffic would go to that particular new system while all the old system is still being used. So the challenges become huge in this case because now you're talking about coexistence with the older system. This is already a hugely complex system, and now you have doubled it in size potentially with a new system also. But now piece by piece you're changing, diverting traffic. And it's not just traffic, it's data, it's hugely complex. How do you really manage that? So if you thought that was complex, this is what the real architecture diagram looks like. The red systems are the new core banking platform systems that get changed. The green ones are what needs to be updated from the bank perspective to make it work with this new banking platform. The blue ones are the external interfaces that get affected by this platform. Not necessarily change in all cases, but they do get affected. And there are some gray ones which are sort of related, but there is no direct impact to them at all. Okay? A very simple diagram, right? And this, at a high 30,000 foot level, we've got 130 systems with 290 interfaces for this banking platform implementation. That is the nature of complexity we are talking about. This is a bank that wants to go on the agile way, and not just go agile, they want to implement continuous delivery on this. Why? Are they silly? Are they stupid? At such scale, in the most optimal estimates, it would take at least 5 years to implement all this. But it is required, it is essential to do that. Why? Because if they implement the right processes and practices, if they actually are able to implement continuous delivery, they'll start seeing value out of this investment in much more quicker increments, which means they can go back to the board and get more funding because no one is going to give them whatever X amount required for it. They'll get fractions of it to say that this is actually going to work. Here's something working, give me more money. Here's something more that is working, give me more money. It is extremely important to do that. Now in the regular software, a smaller, whether it's an offline product, a desktop product or whatever, it might not be as complex. The scale is huge. Okay? So it's very challenging to get onto this path, and there's a lot of important things that we need to keep in mind. So let's talk about some of the execution challenges what come across for this. The bank is business, right? It's business organization. They may have an IT branch, but IT, their main purpose is to support the banking systems, not build new systems. So obviously they are going to work with multiple vendors, partners to help them deliver that. Now, as it comes down to you working with different people, even in the same table, if you have to work together, each one's definition of agile, continuous delivery, processes, practices is different. Now you're talking about large organizations and you're trying to get them aligned in thinking about agile and continuous delivery. Huge challenge. For whatever history, the history we'll talk about later. There are various constraints. One partner may have a constraint of I cannot use a USB or get my own laptop. The other might say I cannot use Skype for communication, I can use only WebEx. While the other might say I use only WebEx but not Skype. How do you get these people working together? They are part of the same team. So constraints are very different, the ways of working are different, the policies are different. Getting them aligned, a huge problem. The next thing is the stakeholders. When I was working on this, when we had got started on this journey, talking from a testing perspective for a project that is not really scaled up yet, I was working with 18 different stakeholders across the client bank, its partners, to make sure they are in sync with what is required to be done from a testing perspective. Imagine when it really gets going, the engine starts rolling and we get moving on that path, the kind of complexities that come through. So it's a big challenge again. Oh, by the way, I forgot to mention the slides and everything will be available on SlideShare later. So if you want to write still, that's fine. Third thing is agile. We spoke about it. The definition of agile, the understanding of agile is very different. Tathagat spoke in very mild words in the morning about what agile means to different people. Martin Fowler has written about agile, one of the people who inked the manifesto. He's come up with the agile fluency model and some basis on which to say where exactly are you on the path of agile, being agile. There is a funny take on this, not the fluency model, but I heard in some place about the different maturity levels of agile. One is a checklist driven agile, where I sort of know the manifesto and I have a list of practices that if I follow those, I'm agile. That's one. Second is the next matured state of really understanding what those principles mean and using the right ones in the context that makes sense for you. Now you're getting more matured in that adoption, understanding and adoption. And third is being truly agile, being agile. You don't need to look at any principles, practices. You look at the team members look at themselves and say, this is not working, let's evolve, change certain things and keep proceeding ahead. So agile is one of the bigger challenges because you all need to, the team members need to have the consistent view of how we are working, why we are working like that, and what value we are getting out of it. Money, we spoke about why the bank needed to go agile and continuous delivery. Trust, for whatever reasons, there was bad blood between the company from where they bought the core banking product. Historical reasons. They definitely move beyond that, but that's still in the back of your mind. Once certain negative things gets in, you are always going to be conscious about it. So big challenge. The other challenges are team distribution and integration. So we spoke about 4 different countries where you are working from. The scope, we saw how wide that scope is. Coexistence we spoke about switching across specific systems one at a time as we get ahead with the implementation. Data migration, because it's not just about moving systems, it's moving the complex data from various different systems in a way that along with coexistence, nothing bad is happening with your data, with your money, essentially. And defect management, because now there's a core product against which there can be defects, there's customization works against which there can be defects, there's new implementation to integrate with other systems, internal or external. How do you really find out where the root cause is and work with that team? That is a huge problem. How do you really get everyone to believe that doesn't matter where the defect is, let's just get it fixed and move ahead? The non-functional requirements, given it's a banking site, no surprise that there was a list of 10 different non-functional requirements. The most important ones, that was not a fire. Security, security, one of the biggest NFRs. Banking product, right? It has to be secure. Performance. As long as it is internal users of the bank, yes, maybe performance you can sort of compromise in a little way. How many times we have called up call center, customer service and say, please hold on, our systems are slow. Right? It gives us an immediate indication of what that could mean. Auditability. If something goes wrong, how quickly can we get back to finding the source of the problem, the root cause, and what could have been done to prevent it? Okay, that is a fire alarm now. We'll continue. Yes. Maybe quite possible. So compliance, government regulations, banking regulations, that is another big factor. And accessibility. How do you make sure even differently abled people can access your product and make value out of it? So in such a case, the code quality becomes a huge challenge because that's where quality really is coming from, right? Assuming the requirements are correct, code quality is where the problems might be. So we've got a core product team which they are developing, they're putting code in their own SVN or version control system, which is getting synchronized to a different version control system which the bank has. And on top of that, there is a that's where the builds also run, tests run over there. And the customization teams, they work on top of that code base. The different integration configuration teams work on that. We also have system testing happening. Can I actually print a checkbook out of this new system, for example, or statements, making sure that is happening. So that's systems testing. And of course, the NFR teams are there to make sure different NFRs are being validated at different points in time. they are all using the same code base. For the scope of this discussion, we are not focused on the system teams or the NFRs. We'll just focus on the other ones. So in such a complex system, how do we really get feedback as quickly as possible? Okay. So if you remember our organization objectives, value, time, and quality, one of the practices that helps is getting a CI system set up as quickly as possible in the right way. I'm assuming everyone knows about continuous integration, right? So I'm going to move on because the next set of things is going to get much more interesting. So in terms of the process itself, how does CI works? When any developer checks in a code, commits a code into version control system, tests automatically start running, whatever different forms of tests are there. And then whichever other developers are using the same code base, before they commit, they'll take the latest code, make sure the tests run again locally, commit it afterwards, and as soon as the commit happens, the test would run again. That's a right way of setting up continuous integration. This part is easy. We've been doing this for a long time. Continuous delivery is something different. The main intention of continuous delivery is to make your releases boring. Why boring? Because in a complex environment, it takes a long time to get all artifacts together, configurations together, and get them in the right environment. The stale data should be removed correctly. You don't want to mess around with that. Make the releases boring at the click of a button. My code is now ready from a QA environment to a pre-prod environment, from a pre-prod environment to a perf environment, along with all configurations and everything else required for it. And in ideal cases, if everything has worked fine, the tests have worked fine, nothing is preventing me from saying go live right now. Everything is automated. That's where DevOps is extremely crucial to get it set up in the correct way, and it can help you get to that next stage as quickly as possible without manual intervention. What continuous delivery gives you is that you can continuously get that feedback from business giving you requirements, you design it, develop it, deploy it, get new requirements from design perspective. The cycle just keeps on continuing. Okay? So enough about theoretical knowledge. How do we really get to continuous delivery? That is the crux. And we'll look at certain practices that will help us get on that track. Now practices can be many in number. The way I look at it, Agile Manifesto has got 4 tenets, which results in, I think, 12 principles. 12 principles can be implemented in hundreds of different practices depending on the teams and the context. What is one of the practice that makes teams successful? Collaboration. What else? Transparency. Focus on value.
Continuous delivery of value.
Continuous delivery. Okay, we are now in a repeated infinite loop. Communication, collaboration, transparency we spoke. What else? Continuous improvement, trust, deliver working software. It's a practice to get to deliver working software. Someone said something. Automation. Yes, we could have just kept on going about this, but we want to get to this specific one. What you are saying is absolutely right. Okay, I'm not. Don't get me wrong. The practice that we are talking about that will really help the teams to get to continuous delivery. First, continuous integration, of course, and then continuous delivery is test automation. Okay. What is a practice that will make teams not be successful? You could easily say not having good communication or collaboration, but okay, in interest of time, I'm going to go with that. Instead of too much automation, I'll say again it's test automation. Why? Because test automation is code. If you do not write that code well, it is not going to help the team, it is going to slow them down, and you have to rely on manual testing all the time. So test automation is something that you have to really focus on. How do you do that well in order to get to the next stage quickly? What is test automation though?
Automating tests.
So writing some code to continuously check if whatever that requirement was that you are trying to test is being met at all times. It's working as expected at all times, right? So it is essentially a safety net. If you have a good suite of tests automated, that safety net will ensure if any of that changes, the team will know about it. I'm saying the team, not the person who's looking at these test results. Remember, it's a team who is going to look at it, right? With this kind of feedback, what you will see, oh, test has failed. Why? Maybe it's something that was working earlier has unexpectedly changed because of some other features that might have been implemented. So it's a valid defect that you have caught, a regression that you've caught out of. Or it might so be the case that the requirement itself has evolved, but we were not having the right set of practices to really update our tests along with that requirement. So my tests are just outdated. I need to update my test to make it in line with what the new requirement is. Both are good feedbacks. In some cases, which is usually the case in functional testing, you also get a lot of intermittent failures. That might be the third reason now.
Is this also an enabler for teams to think about refactoring and re-architecture of solution without impacting the business scenarios?
So the question is this also
Having a good automation, does
Yeah.
it also enable or facilitate?
Absolutely. Will the automation enable to do better refactoring, quicker changes? That's what the question is. Right?
Yes, I mean, people are hesitant doing
Absolutely.
refactoring because they don't know what will break.
Absolutely, and that's a classic case of working on legacy systems where there is not enough automation. Right? And there are different practices that you can apply when working on legacy systems with very limited automation, how you can still get to some level of confidence using automation. But that's a separate topic, so we can talk separately about that. Okay? So why do we do automation? Save time, effort, manual errors,
Coverage.
quality, coverage, sorry you're saying?
Ensuring the quality.
Quality, consistency,
Faster feedback.
faster feedback. Whatever we are saying essentially ties to feedback, right? If something has changed along these lines, you want to know as quickly as possible if it has changed. That is the main reason of automation. So how do we get quick feedback from automation? This core banking product that we are talking about, when the source code comes in, compile all that source code and deploy it. For whatever reasons, that build takes 18 hours. Is that a good feedback loop? After 18 hours of build, then you would deploy and then you would run some tests around it. Is that a good enough cycle to get feedback? The developers have already moved on to doing something else. Context starts getting lost. Feedback is not as quickly as there as it should be. So one of the ways where you can start getting quicker feedback is to think about implementing a test automation pyramid. And when I say implementing a test automation pyramid, let me be clear, it's a concept. Okay? There's nothing like building a pyramid in your product. But what it means is there are various different types of tests that you have, which you need to consider, and these types of tests are dependent on the product you are testing. These would start off from unit tests. You might have integration tests, JavaScript tests, Vue tests, web service based tests, and then your functional UI tests. And on top of this, you will have your manual and exploratory testing. So in Smita's session earlier, we were talking about the testing and the responsibility of testing, right? Developers versus testers. If anyone is able to sign off based on just a QA build going green and say this build is good, raise your hands.
Sorry, can you repeat the question?
Can anyone, any team member or any manager, QA manager, say that my QA tests have gone green, everything is passing, this build is good, we can deploy it to production or take it to the next level? Do we have that kind of confidence? We will add on the manual exploratory testing inputs also from it, right? Is that all the test coverage that is there? Everything contributes to the quality of the code. You cannot get to the granular bits of testing that unit testing and others would do from functional or exploratory. And that is a very important concept. That this whole thing, the results of all these different types of tests is going to tell you what is the quality of your product. So you need to look at all of them. To look at all of them, doesn't matter who's implementing it. What is important is looking at all these inputs, collating them together and saying, okay, everything actually seems fine, now we can go to the next level. So what this really means is, up to the Vue tests, these are technology facing tests. For some reason in my UI, I want to change a radio button to a checkbox. The implementation of that technology bit can be automated using a technology side test. It can be from JavaScript or from unit test, whatever it might be. But the main point about why is that change required as a manager, if you are saying, if you are a product owner and you say that I want to change this from a radio button to a checkbox, what is the business thinking behind it? What is the product requirement for it? And that part of testing actually comes from a business facing perspective, an end user perspective. And what this means is your web service and UI tests, they are focused on business side versus all other types of tests, they are faced on the technology side. Now, what this pyramid, yeah?
This to add to your point that yes, spoke about traditional versus agile. Traditionally, only go by manual testing and or the testing team testing, and let's say the ownership lies in them. If you're going to agile, the ownership is distributed. The dev team is as responsible for the quality of the product as the testing.
Absolutely. Quality is a team responsibility, not just a testing team responsibility. Right? The other aspect of this pyramid, which is not very evident from here, is the time it takes, or rather the cost to implement these tests keeps growing as you go from bottom of the pyramid to the top. Why? Because a unit test you can implement and run on your machine, the developer machine itself. I don't even need to compile my whole source code. I'm making change to one class, run test for that particular class and related. I know if that feedback is there or not, even before I start making changes to something else. Right? The time it takes to execute these tests also keep going up. Why? Again, same reason. A developer is running tests on his or her machine versus now to do a JavaScript or a web service test, I need to start pulling in more things together. What it means, I need to commit my code, pull more things together, build, deploy, whatever is required to get that going. And especially that's the case for UI and web service, right? You need the whole product built and deployed in some environment before you can run any of those tests. So the cost to implement those tests and run those tests has gone up tremendously. What that means, the feedback cycle is now getting delayed progressively. Okay? The thing which the pyramid does not very explicitly talk about is this inverted pyramid in the background. The inverted pyramid is actually the impact of each test on the product. A unit test is having an impact on the granular bits of the product, versus as you keep going up, the view test now has got impact on a wider range of the product. UI test has a maximum impact on the product. So all those who are doing testing over here, the testers, please ensure our UI automation is not granular. I'm not just testing if I'm getting a JavaScript error or not. It is very futile to do that. It is going to give you a lot of delays from your feedback cycle. And that's where the reality really seeps in, right? If you look at it, the ideal is one, but in most cases, you would see this kind of scenario, an ice cream cone effect of your pyramid. What this means is you've got still the same type of test automated, but look at the number of tests that are really there. The whole focus of the team is about testing from a UI layer, the functional aspect. The QA team is doing this. How many of us have full reliance on that automation? How many of those hundreds or thousands of tests are really giving proper feedback in good time? And if you want to do a quick production defect, can you wait for 2 days for your test cycle to complete? Not at all. What you're going to do, you're still going to rely on your manual regression over there. So you're not solving any problem by keeping on adding tests at the UI layer. You're just compounding the problems. That's the first reality. The second anti-pattern that we see is two pyramids. One is a developer pyramid, the second is a tester pyramid. This is a classic case of a wall in between these roles. This is your responsibility, this is your responsibility. Don't talk to me about this or not. What this results in? There might be duplication of tests, that's the first thing. But duplication as a QA manager or as a manager, I'm happy living with, right? It's just more tests doing the same thing, which is useless, but fine.
Different goals.
Sorry?
Different goals and not common understanding of the...
Exactly, and because of that, what happens is you might miss out on automating some scenarios. You might miss out on testing some scenarios which you might have assumed, oh, the dev should have taken care of this at the unit level, for example. And those scenarios are the most crucial ones. They are typically your edge case scenarios or weird ad hoc scenarios, which if it happens in production can cause a lot of pain. So this separate way of working causes a lot of problem. Okay? The third anti-pattern, which is sort of a combination of these two, is called a cupcake anti-pattern, where you don't have the proper separation of tests at the right layer, and still you've got a very big manual cycle. Okay? So now how can we use this information from an automation perspective to really get to continuous delivery? That is what we are here for, right? We need to understand how to get quick feedback. What are ways you can get quick feedback? And if we can focus on that from our team perspective, a small team perspective, which might be 2 tables or 1 room, whatever, and if we start getting the practices in place over there first, it is easier to spread that knowledge and that learning to different teams as well, which are related. So what is the approach that I took for this particular bank? And I have to put a disclaimer over here. This is a long journey. I was involved with this project for the first year and a half, and it's been a year and a half since that time. They're proceeding, but I don't really know how that's going. But I thought this makes really logical sense on how to get that quick feedback for the team. So let's look at a legend of sorts, right? If this is the pyramid that is applicable for this core banking platform, for whatever reasons, unit tests, integration tests, web service tests, functional UI tests, and manual exploratory tests. We are not talking about NFRs over here, right? This is what our pyramid looks like in terms of what type of tests are applicable. And just to recap, this is our scope. This is what needs to change in terms of a banking implementation. Let's start off from a developer machine. Think about what are the tests that the developer can run on his or her machine before code can get into the version control system. Definitely unit tests can run there. Integration tests can run there. Maybe some form of web service test might be possible. And maybe some UI tests might be possible. You don't need the whole thing anyway, right? Now to run all these tests on the developer machine, teams need to put in effort. This is where the tooling becomes important, the practices become important. How can I quickly build the code which is relevant to my scope of change quickly? I can't wait for 1 hour, forget 18 hours. I can't even wait for 1 hour for every change that I do. So how can I run those tests quickly on my machine? What can I do in terms of running my web service test potentially over here, or my UI tests? Maybe the UI is a workflow, right? Workflow, and I'm actually making changes on the 3rd screen of the 10 screen workflow. I don't want to go through screen 1, 2, 3 every time I want to make the changes. So what tools, practices do I need to get in place in form of stubs, mocks, whatever is required to say, get this state ready, open up the browser to that 3rd screen directly, and let me run my view test over there, or my UI test over there. Takes a lot of effort. What we're talking about legacy systems, right? This potentially applies over there also. The reason it is difficult to refactor in legacy systems is because of this problem. But if you're able to break it down, then you'll be able to start writing some tests around that as well. Now if a developer says, I've run all the tests that are relevant to the changes I'm making, it's not the whole suite, right? You don't want to take the developer time away for that whole thing. All the relevant tests, if I'm able to run over here, then I'm going to say now SVN commit or give push, whatever that might be. And now my code is there in the next environment, which I'm calling as a stubbed environment. Why is it a stubbed environment? Because I don't care about all the other integrations and all. For my team itself, I want to make sure everyone who's putting in code over there, we're able to run the same type of test. But of course, now I've got more code compiled together. Let me run a little bit more of my web service test over here. Because that is now feasible. I have that code available. Let me run that. Maybe my UI tests also become a little bit more in that sense, right? The number of tests that I run. And it becomes feasible to get that kind of input again from a stubbed environment perspective. Now if my stubbed environment is okay, what next? I go to my semi-integrated environment. In semi-integrated, I don't have my external systems or my other banking systems over there, but my teams itself, which might be loans, collections, customer facing, term deposit, whatever those different teams might be, getting all that code together without the external dependencies, banking or otherwise, getting all of that together and running those tests again. But now in this case, it probably doesn't make sense for me to run my unit test. Why? Because unit test is looking at a very granular piece. Even if more code has come together, unit aspect is not going to change. So maybe I can optimize what type of tests I run over here by reducing this, but now I've got more of my UI tests going. Okay? And it proceeds accordingly. I get to my pre-prod environment. Over here, I may not need to run my integration tests, the full suite of integration tests. Right? Why others might be required? Because now you actually have integration tests going on with other systems also. That has come in at this point in time, which was not the case earlier. And likewise, you get to your pre-prod or UAT environment, where again these tests are not applicable, so you just run these whatever is applicable. So what does this really mean? That this particular way of segregating, thinking about the environments, to say which environments are applicable for my context, my way of working, my team distribution, and the actual work that is going on. I might require 15 different environments, but I can get really quick feedback from them. Now, of course, let's be practical. Getting 15 environments, it doesn't make sense. Even if business is saying, okay, we'll give you the money, it doesn't make sense. So you start optimizing at that point in time to say, maybe out of 15, maybe 5 or 6 is good enough. But think actively about those. So the way we categorize our tests as UI or a unit or whatever, right? Add a dimension to that categorization of saying that this test is applicable to run in which environments as well. So a test framework now needs to support it to say, for this environment, I'm running this type of test. So pick up only that subset and run it. It needs a lot of effort from an automation perspective to build in this kind of configurability. It adds more discipline requirements from the team perspective to really manage that. The other aspect that I really wanted to talk about is more on the, again, the ideal pyramid side. Why it is more important to reduce the number of UI tests. Have we heard of smoke, sanity, regression, and what are different categorizations of tests? Are they applicable for UI tests or any type of test? Sorry? Smoke can be done anywhere. Ideally, you can do it anywhere. You can put categorizations anywhere you want. But where do you really see that? Mostly, I see it in UI testing. Because my unit testing tests run so fast, I could parallelize them on to run on each core of every developer's machine. Everyone has got multi-core machines, right? We have tools to say one core is utilized for running the unit tests in the background. No one gets disturbed by it. It can be configured that way. They run really fast and you can get feedback literally in a few minutes, even for thousands of tests. With the right practices, you can do that. So why do you need to have a smoke sanity in that case, unit test? The reason we really see these categorizations in UI tests is because these are just so slow. You need to get feedback. I cannot wait for 1,000 tests to tell me my login itself failed. That's why I want to do my login test first as a smoke test. If that is fine, my Active Directory is set up correctly, now I can run my sanity. It is just to reduce that feedback cycle. So now to reduce the feedback cycle, you want to start not just categorizing tests, you want to start pushing them lower in the pyramid as quickly as possible, so the team knows as quickly as it is. Right? So, what does this mean? Coming back to it. The other way around. A equals B doesn't mean B equals A in this case. But, yes, this is a funny takeaway from what I said I will prove. So I don't need to say sorry. Okay? So what does this really mean for us, right? From a continuous delivery perspective in large complex projects. What are the takeaways we can take away in terms of processes, practices that we need to keep in mind to implement and start going on this journey? First, think about processes, then practices, then tools. That is the sequence. It is not tools, practices, processes. You may have a lot of money spent already on licenses. Don't start off using that license-based tool as a first thing to say, how do I use this tool in my journey? It may not be the right fit. Think about what is the ideal process based on a lot of context, domain, expertise, distribution, skills, capabilities, tech stacks, who's going to be doing automation, so many criteria. And think about what process will actually work for your team to take it forward. Based on those processes, what practices do you need to implement to achieve those processes? For those practices, what kind of tooling is required? That is the right sequence. Then, you need to identify the correct and appropriate environments. Challenge management to say with proper data points that if we have so many environments, we could be running our tests in this fashion and get the feedback quickly. It will help you and the team to really make sure the quality is of the highest level at all times. Do smart automation. What we spoke about, configurability, categorizations, these are just a few things to keep in mind about automation. There's a lot more that is required. Be smart about it. Identify tests for specific environments along with that framework support that you have now. Any test that you are picking up, whether it's a developer saying, okay, this is a test I want to do from a TDD perspective or unit test perspective, or a QA saying, this is my functional test that I want to automate. Have that strong conversation to see, does it make sense to have this test at this higher level? Can I push it down? Have that conversation. So instead of having 10 tests for different JavaScript type validations or rule validations, have one test at a UI level, which sort of ensures the error messages, everything is coming correctly. The rest of the tests implement as JavaScript tests. That's where the logic is in most cases. Have those conversations. It will reduce the number of tests you have on the top. Give you quicker feedback. Okay? Categorizing of tests we spoke. DevOps practices is extremely important. Now you've increased the number of environments from just a developer environment, QA, pre-prod and prod. You've added a bunch of environments. You don't want to be spending time in deploying the code and configuring it, including data management for each of these stages. It has to be automated. Testing cannot work in isolation in such cases because quality is team responsibility. All different types of testing give you the sense of what the quality of your product is. So QAs have to be, or testers have to be sitting with the developers, with the product owners or BAs, whatever the relevant roles are, which is essentially including DevOps for that matter, making sure that is done correctly. And again, you get that quicker feedback to the developers or whoever is implementing. Test consolidation is another very important activity. As the product really evolves, the same test that you had written in the first case might not be valid anymore. Or maybe it is covered as part of something else. Delete older tests. It's okay to have fewer tests which give the same value or better value than having more tests which is not adding any value. Very important. Maintenance. This is something about refactoring, related to refactoring. Developers will typically get tech tasks or tech debt and they'll get time allocated to work on it. From an automation perspective, rarely will you get time to work on automation-based activities, refactoring or updating frameworks. Make sure that is part of the original estimation, and maintenance and consolidation is part of a day-to-day activity, not a separate activity. Test prioritization. Again, it comes down to how you're going to run the test, in what fashion, what is going to be the sequencing. Having everything in a common repository is again very important, because if you expect the team to be owners of that quality, as a tester, I should be able to look at the unit test or web service test to see if that coverage is already there. I don't need a functional test for it. At the same time, developers should be able to look at what functional tests are there and saying, oh, this is another scenario, I should tell the QA or whoever's going to be testing it, this is something additional you need to look at it. Common repository is extremely crucial. And at the same time, a single dashboard is very important, because without that single unified view, you would never get the team to really own that quality. So the question is, in terms of scaling for a large project, this is a simplified example, how do you really deal with it in that case? You have to start segregating. Of course, if it's a 300 or a 500 or 1,000 people team, for whatever reasons, you cannot have a same dashboard for all of them. Maybe it's just a highly aggregated one. So in that case, one CI server will also not work potentially. Maybe you need 5 CI servers based on which teams are doing what. It might still be the same code repository, but CI servers might be different, which is fine. How do you aggregate it, segregate and aggregate? That is important. Providing it as a unified view for a team, not saying this is for developers, this is for QAs. Instead, this is for this team, this is for this other team. That makes a big difference in the team owning the quality and responsibility of that. Absolutely, absolutely. Because none of this can get implemented. If we are all technologists out here, no managers, we might agree to this, but business has to fund it. Right? So everyone is essential to be on board with this kind of approach to say, how are we really going to give that quality? Okay? So to end it, yeah.
When we're talking about in the previous slide as well as previous to that, in the Pentagon, when we're talking about various environments and identification of the various environments, right? So what we're saying is, given during the delivery of the phase to have different environments, or is it different environments mapping to different phases of the project?
I think it's a much more loaded question. If it's okay, we can take it offline. Yeah. But the point is that the team is the right set of people to decide, do you need environments per phase or what it is. You might be able to use the same environment across different phases, maybe, maybe not. It depends on the context of the product also, how much sharing is going on.
The kind of categorization which I see in the Pentagon, they are primarily, if you talk about a old waterfall project, it's all the different phases of the waterfall project.
Yeah.
So, and comparing it with Agile, where we say continuous delivery, we're delivering it every iteration.
Yeah.
That's
Yeah.
bit of a.
It is, and even for this banking case, if I actually come out with it, we had identified, I think, about 15, 20 different environments, keeping it simple. But it's not feasible because each environment potentially needs 5 high-end servers for it. No one is going to give that. So anyway, we can talk further on this aspect, right? So we have proved that a triangle is equal to a pentagon. Or is it? I don't think so. It actually depends on what your product is, what kind of environments are there, what kinds of tests you need to run in which environments. It can become an n-dimensional polygon for that. Okay. So with that, thank you so much. I'm available tomorrow as well. I'm doing another talk tomorrow. But any conversations, offline conversations, happy to have that. Thank you so much.
And May I request Loretta, please?